In this demonstration, we have an object that can show a visual of the waves generated by a person. The source of the wave is the initial disturbance that triggers the poles to each vibrate in turn in a wave of energy. This mechanical wave is clearly visible and is transverse in shape. You can easily see the crests and troughs of the wave, and measuring the frequency, wavelength, and speed of the wave would be fairly simple. Sound waves are also mechanical in nature, but these waves are generally not visible to the human eye and are longitudinal rather than transverse. Mechanical waves can also be generated by a slinky. These waves are transverse and are generated by the perpendicular motion of Ms. Shire's hand in respect to the direction of the wave's energy. The amplitude and frequency of the wave is being varied. Here, Ms. Shire started to generate longitudinal waves by moving her hand parallel to the direction of the wave's energy. These waves can be measured by the distance between the rarefactions and compressions that can be seen. Here, it is interesting to see the destructive interference that occurs when two waves collide. Another example of mechanical waves can be seen by a drop of water. When the drop hits the body of water, waves can be seen. These waves are transverse because the water is moving up and down, and the initial disturbance was perpendicular to the outward direction of the waves. These water waves are moving out radially, as seen by the circles moving outwards with increasing diameter.
This demo is an example of visible light waves, which occur between infrared waves and ultraviolet waves on the electromagnetic spectrum. All electromagnetic waves are transverse and can travel without a medium. To show this, we are using firework glasses and looking at the ceiling lights. These glasses use holographic diffraction grating lenses that break light into the full spectrum of visible light. A diffraction grating is used to separate light waves by their wavelengths. Using these glasses to look at the overhead light, white light is separated into the full range of colors on the visible light spectrum. These glasses can also be used to look at tubes of gases excited by an electrical discharge to view their atomic spectra. In the second example, we are showing radio waves. The nature of this wave is electromagnetic, and the shape of the wave is transverse. The radio station that you are tuned into transmits the radio waves. The radio stations use a broadcasting antenna to transmit electromagnetic waves at hundreds of thousands of watts. Your radio antenna receives the waves, and then a tuner separates the signals using the principles of resonance. Radio waves occur naturally from space, emitted by stars and other celestial objects. Radio waves have the longest wavelength and the shortest frequency on the electromagnetic spectrum.
Here we are using microwaves to heat a cup of water. Microwaves are electromagnetic waves with a transverse shape. They are generated by a magnetron and other devices that can generate electric fields. They transmit energy to objects that contain water and do not pass through or penetrate materials such as metal. You can create a microwave by vibrating a molecule in a crystal or another solid mass. Examples of microwaves include the appliance that you have in your kitchen and a radar gun which the police use. On the electromagnetic spectrum, microwaves fall between radio waves and infrared waves.